Hi guys, welcome to your last flipped video. Our last lesson in topic 9 is lesson 9-7, solving systems by linear and quadratic equations. So in this lesson, we're only going to focus on the substitution method for now. And what we're looking for is two equations that we can set equal to y. And so we'll see kind of two versions of this. We'll see equations set equal to each other, and we're going to separate them. And we'll see equations that are already set equal to y for us. And in general, in every question we're going to see in 9-7, we're going to have two equations, two of them. That's what a system means. One of them is always going to be a straight line, linear, and one's going to be our parabola, the quadratic equation. So example 1 just says, why are the solutions of a linear quadratic system of equations related to the solutions of a quadratic? Well, just like we had with x-intercepts, when we look for our solutions in all of topic 9 up until this point, we look for x-intercepts. And with x-intercepts, we decided there's three possibilities we could have, 0, 1, or 2 solutions. And that is the exact same case with our solutions that we're going to see today. When we see a linear quadratic system, we are going to always have one straight line, like we see here with the purple line, and one parabola shape. Now, looking at these three options, the red, blue, and green parabola, we can have these same options for solutions. We can have no intersection that indicates 0 solutions. We can have one intersection point that is equivalent to 1 solution. And we could also have places where we intersect at 2 points, and that will indicate 2 solutions. So today, you guys, we're looking for intersection points. This is the first lesson where we are taking a break from x-intercepts. We're looking for where these two equations are going to cross each other, and those will be our solutions. So firstly, we're going to see how can we do this by graphing. So just want you to go to Desmos, and I want you to type in these two functions. Now in Desmos, or even in our graphing calculators, we don't need to include the y. So we just need to type in x and x squared. And when we do, you guys, you're going to see something like this. You're going to see our blue graph, which is our quadratic. And then you're going to see our straight line, which is red, and that is our linear function. This is a linear quadratic system. And our solutions are where they intersect. And if you do this on Desmos, you can highlight over those points right away and see what those exact coordinate points are. We should see that that is 0, 0, and 1, 3. Those are our two solutions to this system. Let's go ahead and try it again, except now, instead of seeing y equals two separated equations, we have just one whole equation here, and they're actually set equal to each other. Now, when we set something equal to each other, guys, that means that we're ready to find our points of intersection. And all we need to do extra in this problem, compared to the last one, is to separate the two parts of our equation into their own equations. So that's where we get our first equation from, y equals 5 minus x. And our second equation, y equals x plus 3. We're going to treat those like two separate equations, and we're going to find what they look like. Now, by all means, you can go to Desmos again and just type in your two functions. Absolutely. I want to remind you how we can do this by hand. Anytime we have an equation, we can plug in any numbers that we want and find their outputs. Those are coordinate points. So, just as a refresher, we always use the 5 numbers -2 to 2, and we're just going to take those, and one at a time, we're going to plug them in for x into our equation. If you're doing this on your calculator, make sure that you're plugging it in with parentheses, and here are the values that we're going to get. When we plug in -2, we get 1. When we plug in -1, we get 4, and here is the rest of those values. If I head over to my graph now, you guys, we just need to plot those points at -2, 1, -1, 4. 5's our y-intercept. And you can see that we have formed this parabola shape. Go ahead and graph that yourself. Check it on Desmos, and it should look identical. Now we're just going to do the same thing with our second function, y equals x plus 3. Type it into Desmos, or we can plug in the same x values for x to get out our y values. And this is linear, so we're going to see that they should increase all at the same time. And this time, this should form a straight line. Let's see if it does. All right, so we're starting to see the linear function and the quadratic. We always have a straight line and a parabola. And again, we're looking for our points of intersection, and we can see those exactly. Here's one solution. Here's two solutions. We're going to name those points exactly at -2, +1, and +1, +4. We can see that those points were also the same in our tables. All right, if you're feeling good, go ahead and try these next two on your own. Same thing, we are just going to go right into Desmos and we're going to type these in. So when I go to Desmos and I type in x² + 1 and x + 3, I'm going to go ahead and draw a sketch of what I am seeing on Desmos, and I want you to do the same. All right, so right now I'm just drawing a general sketch because when I go on to Desmos and I type in those two functions, I can hover over these points of intersection right there, and I can see clearly that those two solutions are -1, +2, and 2, +5. All right, second one over here, same thing. We're just going to take our starting equation and we're going to separate it into two equations and look for their intersection points. Go ahead and punch those into Desmos and draw a sketch of your parabolas and your linear equation. All right, guys, so again, these are just rough sketches. We need to be able to draw a rough sketch, and simply we're just looking for how many times we intersect and where exactly with our two functions. And this time we're going to have some decimals, and that's okay. Our first solution is at 3, 0.5, and -2, +3. Again, Desmos is going to be huge for finding these for us. All right, how can we, instead of graphing, how can we do this by hand? So let's take a look at this first function here, and it looks like they have already separated our two functions for us. So here's where in our vocab we wrote down the substitution method calls for we need to have a y equals and a y equals. And what we're going to do is the exact opposite of what we had before. We actually want to set these equal to each other. So if I have two y equals, I can now ignore the y's and just set these two parts equal to each other. It doesn't matter which one goes on what side, but we do need to set those parts equal to each other and forget about the y equals. By all means, guys, we can go to Desmos and we can graph these and find their intersection points, and I think that that is a stellar way to check your work. But now here's how we do it by hand. Our goal is to try to get everything, let's write this down, goal, everything equal to 0. So in other words, we have to get everything on the same side of the equation, and then we want to try to somehow factor. Let's see how that's going to work. All right, so I'm going to draw my line down my equation, and I want to get everything set equal to 0, and I think it's going to be easier, I think it's going to be easier to get the left side set equal to 0, and what I mean by that is there's just less numbers to move. We're going to move these two numbers over to the right-hand side, one at a time, or you can do it two at a time if you'd like. But I'm moving these terms over just by doing the opposite, and that allows the left-hand side to be equal to 0. This x², let's go ahead and bring that down. These guys are like terms, so we can combine those to get -8x. And again, some like terms here, add those together to get 12. So everything is set equal to 0. Now we're looking to factor. Remember, our factored form we can only do if we are set equal to 0. and we're looking for two numbers that multiply to C and add to B. So multiply to 12 and add to -8. I'm thinking it's going to be, let's see, 4 and 3 I don't think is going to work. Maybe 6 and 2. I think that's going to be our winners. Now, in order to get these two numbers to multiply to +12 and add to -8, they're going to have to both be negative. So we go ahead and factor, and how do we solve this? Well, you guys know we set these equal to 0, and we solve them. Now, let me back up, and I'll do that for you. So we set our first factor equal to 0, and we solve for x. When we do, we get x equals +6. And same thing over here, x minus 2 equals 0. Solve that, and we get x equals 2. Now, here is the first half of our answers, you guys. We're looking for our solutions, and we just found that our two x values have to be 6, and they have to be 2. We still don't know the y values, so you guys remember, how do I find a corresponding y value? We just have to take those numbers, and we got to plug them back into our functions. Now, it does not matter which function you plug it back into. So let's just do both for this first one. We're going to plug in 6 for x into both of our equations. Go ahead and solve that through, and we should be getting the same answer for whichever equation we plug it into. All right, when I plugged 6 into my functions, let's see, we would do 2 times 6, which is 12, and 12 minus 4, we should be getting 8. And I did the same thing with the top function and got the same exact answer. Now let's do the same thing with our second solution. We want to plug in 2 for x now. 2 times 2 is 4, minus 4 is 0. So these are our two solutions. If you graph this on Desmos, again, this is where our two functions should be intersecting each other. All right, let's go ahead and try one more. We'll go through this one a little bit quicker. If I have two equations that are set equal to y, we can go ahead and set those parts equal to each other. So there's my linear equation and my quadratic. And our goal is to get this set equal to 0 and then factor. So since I have even terms on both sides, it really doesn't matter which way we go. I tend to side with wherever my quadratic is, the x squared. I want to keep that where it is. I could move it across, but I actually like to keep it where it's at. So that tells me that I should move these other two terms over to the right-hand side. When I do opposites, those cancel and equal 0. So on the right-hand side, we are now just left with an x squared plus x. And here's my like terms that I can combine together to get -6. Let's jump right into factoring. Two numbers that multiply to -6 and add to, this is a +1. Thinking it's got to be 3 and 2 somehow. So 3 and 2, it's going to have to be a -2 and +3 to get to the +1. All right, go ahead and plug those in. Here's our factored form. Our two solutions are x equals -3, we flip the sign, and x equals +2. So those are the x values in our solutions, but we still need to find our missing y values. So I would choose the easier looking equation and plug these back in. The easier one is always typically going to be linear. So we're going to plug those back in, and I'll show you how we solve for that now. So plugging in -3 for x, we get 3 plus 4, which is 7. If I do that same thing here, we're going to get 9 minus 2, which is also 7. Again, it doesn't matter which one you plug it in for. Choose the easier one, save some time. All right, now I'm going to do the same thing with the other x value. So that was +2. Solve this through, we get -2 plus 4, and that is +2. All right, guys, here is our final solutions. Let's go ahead and bring this into a real-life situation. We have a phone company that launches the sales of 2 phones in the same week. The phone on top is an upgraded version of the other phone. During which week are the sales projected to be the same for both phones in thousands? What will the weekly sales of each phone be for that week? So based on the equations that they give us, it looks like X is going to be our amount of weeks, and Y is how much it's going to cost, how much we make in sales. Really, we want to find when are they going to be the same. Right, here's that word same. And what that means is we have to set them equal to each other, just like we've been doing in this whole lesson. So we set our two equations equal to each other, and now our goal is to solve. Just like before, our first goal is to set this equal to 0, and then we can try to factor. So that first step, I'm going to move the 20x over to the right side. Get this set equal to 0. And we have some like terms we can combine. That's going to be 40x. All right, let's try to factor. This looks a little bit different, you guys, than our last two problems because this is not a quadratic trinomial. This is a binomial. There's only two terms. So let's first see if there is a value we could try to factor out. Can I try to factor out that a value? And the answer is yes. We can divide each of those terms by -2. And when we do, we can divide those by -2 and get this. Now, you probably heard some hesitation in my voice there because I noticed there might be something more we could factor out. Took me a minute to see that we actually have a variable that we could take out as well. We can factor out 1x from each term as well. So I'm going to add that to our GCF out front. And now, here is what we're working with. -2x on the outside. We divide each of our terms by that, and we're left with just an x and -20. So this is, remember back here in our other two problems, when we have our two factors, we set them equal to 0 and solve for x. These are our two factors. It just looks a little bit different with our GCF. So we're going to take each of those, and we're going to set them equal to 0, and again, solve for our x values. First one, when we solve it, we just divide by -2, and 0 divided by any number is just 0. So that's our first x coordinate, and second one is +20. All right, so since we're talking about a real-life situation, we want to go with our positive x value. 0 is not a positive or a negative number, but 20 is the value we want to go with. Whenever we're working with a real-life situation, we want to go with our positive value. And even if I were to use 0, when I plug it in, we're just going to get 0 as well. That's basically like our starting point. At week 0, we had 0 sales. So that makes sense. We want to find, though, after week 0, when are they going to be equal? So to find our missing y value again, we just have to plug it back into one of our functions. You can plug it back into one or both. You're going to get the same answer every time. I will always default to using the easier equation. And for me, that is our first one. 20 times the x value, 20 times 20, we get 400. So after 20 weeks, we make $400 in sales, and that is going to be the same for both phones.